Okay, I wanted to go over the mixed review homework, page 41 in the lab manual. Um, so number one, g of t equals parentheses 2t minus 1 quantity squared. Since you have a binomial, two terms squared, this is a chain rule. And the chain rule is the derivative of the outside times the derivative of the inside. And so the outside, what we mean by that, that's just our way of saying that you want to treat this parentheses here, the inside, like there's nothing there, like it was just u squared. So if you took the derivative of u squared, um, that would be, right, the notation, that would be 2u to the 1 if you reduce that exponent. So that's the first part of the chain rule, is you just pretend that that's one thing, u squared, and you take the derivative of it. So that would be 2 times that one thing unchanged. You don't change what's in here, and then you reduce that exponent by 1. But that's only part of it. That's the derivative of the outside. And then you multiply it by the derivative of the inside. So the inside is this 2t minus 1, and the derivative of that is, the derivative of 2t is 2, and the derivative of 1 is 0. And you can leave the answer like that. And it's not too hard to say that that's 4 times 2t minus 1. So I don't blame you for doing that. So while I have you, I want you to understand that you're going to be putting these derivatives into Excel. And so you want to try to think about what would be the easiest way to do that. You don't want to simplify too much, but obviously this isn't too tough. 2 times 2 is 4. There's no need to distribute and make it 8t minus 4, but you can. It's not that complicated. That's okay. All right, now let's move to the harder ones. And number 5, q of r equals the square root of r cubed plus 2r times r squared minus 4. Those parentheses are very important. And you cannot take a derivative of a radical. You have to rewrite the radical using rational exponents. So that gives me a chance to do a little bit of algebra review. The nth root of x to the m can be rewritten as x to the m over n. Anytime you have a radical, you want to rewrite it using rational exponents. The index to n goes in the denominator. This isn't a derivative, this is just a rewrite. So we have a radical here, and so I like to, sometimes I'll have students write the words rewrite just so we know we're not taking a derivative yet. And everything under the radical is going to go to the 1/2 power. So I have these extra parentheses here to make sure you know that this whole thing is to the 1/2 power. Now in my key, I used another algebra rule that says that if you have a times b to the p, you can take that p and give it to both the a and the b, but that's only because there's a product there. But I noticed in much of your work you didn't do that, so I'm not going to do that here. What I'm going to do is I'm going to recognize that there's a lot going on in this parentheses raised to a power. So this is the chain rule, and from up here I didn't quite finish writing. Remember, the chain rule is the derivative of the outside times the derivative of the inside. So that's what I'm going to do here. So the derivative, q prime of r, if I treat that whole parentheses as one thing, that's like u to the 1/2 power. Well, u to the 1/2 power has a derivative of 1/2 times that whole thing, u to the negative 1/2 power. And so everything that was in here doesn't change. Okay, so 1/2 times that inside unchanged to the negative 1/2, that's only half of it, times the derivative of the inside. Now, the inside is a product, so you have to use the product rule right here. And so the product rule is first times derivative of the second plus second times the derivative of the first. So the first would be r cubed plus tr in parentheses, and the derivative of the second, well, r squared minus 4 has a derivative of 2r, plus the second, which is r squared minus 4, times derivative of the first, which r cubed is 3r squared, and then the derivative of 2r is plus 2. So now I have the derivative of the outside, where I pretend there's nothing going on in here, times the derivative of the inside, which is the product rule. Now notice these brackets I put in here. That's because of this plus. So this is one thing, and so that actually belongs to both of these. So if you don't put parentheses around here and you type it into Excel, which is where we're headed, you won't get the right answer. And yes, you would type this entire thing into Excel, and you don't need to simplify it. I don't want you to. So a lot of people took this and put it back under a radical and made it some denominator 2 over the square root. If you did that on your own, that's very good, but really it's just best to just leave it like that, and then when you put it in Excel, you're going to have to add an extra set of parentheses around that, or I would just use negative 0.5. But we have to set our sights on Excel, and so we're not going to do any simplifying. Okay. All right, next one is 7, and 7, saw that most of you did quotient rule, so that's what I'm going to do. The quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So no radicals to rewrite, so I'm just going to take the derivative. The bottom is x minus 9 to the 5th times the derivative of the top. Well, the derivative of the top is 4 minus the top, which is 4x, times the derivative of the bottom. Okay, now when we take the derivative of the bottom, we have to use the chain rule. So the chain rule says that you're going to treat this as one thing, like u to the 5th, and take the derivative of the outside. So this to the 5th has a derivative of 5 times this unchanged, and that 5 is going to go down to 4 because you subtract 1. Then you take the derivative of the inside, well, that's just 1. So we have bottom times the derivative of the top minus the top times the derivative of the bottom, which is the derivative of the outside times the derivative of the inside, all over the bottom squared. And you can leave it like that, or you can use this rule. The other rule here would be like if you have a to the m to the p, you can multiply those exponents together. So you can create that and call that 10, or you can just leave it that way. In fact, that's how I would leave it, because 263, that's what we do. When you type it in Excel, you don't have to type in this 1, and you can type in 10 there. But that's it. I noticed when some of you did this, you pulled the constant out. That's okay, but it just makes it a little more complicated in my opinion. You have to just remember that it's there. I just use the quotient rule. All right, and then the last one, number 10, we have to see, and this is not quite like your project. This 5 is a constant. If there were an n in between, like this, that's like a little bit like your project. That's the product rule. You would have to do first times derivative of the second plus second times the derivative of the first. But this is just a constant. But what we do have is we do have a product. So to take this derivative, we need the product rule. And the product rule is the first, which is 5e to the n, times the derivative of the second. Now the derivative of 6 is 0, and there's a negative 1 here, and the derivative of the natural log of n is 1 over n. So 6 is gone, and you have negative 1 times 1 over n, which is negative 1 over n. So that's the first, that's the derivative of the second, plus the second times the derivative of the first. Well, this derivative constant comes down, and the derivative of e to the n is e to the n. And again, I would leave it just like that. There's no need to simplify. You can leave it like that. Now, this is not too tough. If you wanted to make that negative 5e to the n over n, that's fine, but we don't want to multiply this in or anything like that. Just leave it unsimplified. Okay, go ahead and learn how to do it that way. It's easier. If you're trying to simplify, you're really not appreciating this class. Honestly, it's easier than Math 271. Same thing for Excel. If you didn't learn how to use Excel to solve complicated problems by goal seeking, you got to learn how to do that. Okay, that's it for this video.